Hi, my name's Tony Preston, and in this short video we're going to run through some of the basic functionality of Agilent's N9342C handheld spectrum analyzer. If you want to learn more about the N9342C, then make sure you get a copy of the complete user training and application tutorial DVD, which you can obtain free of charge from Agilent. It runs for about an hour and provides far more detailed training on a whole range of practical topics, such as making interference measurements, measuring modulation characteristics of carriers, sweeping antennas and diplexers. And if you've not done so already, you might like to download the PDF of this Agilent N9342C demo guide so you can follow along during the course of this presentation. Let's start with a quick overview of the instrument. As you can see, the instrument is extremely rugged and ideal for field operations. In addition, it has an extremely bright daylight viewable display, ideal for use outdoors in bright conditions. But when working in a communications room or other dark environment, the built-in light sensor can be set to automatically reduce the screen's brightness, making the display easier to view and saving battery life. When we dim the studio lights, you can see that all the front panel keys have a backlight that can be set to automatically turn on when required. Just refer to page 6 of the demonstration guide for details on how to configure this. On the top panel we have the main RF input, the DC jack for externally powering the instrument or charging the internal battery, a small USB connector for connecting the instrument to a PC, a large USB socket for a USB memory stick, audio headphone out for listening to demodulated audio, an Ethernet connector to connect the instrument to a local area network, an RF output socket if you have the internal tracking generator option installed, a probe power socket for connecting an active RF probe, a dual purpose BNC socket for connecting an external 10 MHz reference clock or externally triggering the spectrum analyzer. And even though the instrument has a built-in GPS receiver and internal antenna, you can also connect an external GPS antenna to this socket here. Here's the instrument's power button. Just press that to toggle the instrument on and off. And to the right are a range of function keys for setting parameters such as the frequency, span, amplitude, bandwidth, etc. And press the shift button for functions such as save and recall, adjusting display settings, the sweep time, etc. As with most Agilent instruments, there are 3 ways of adjusting a value, using the numeric keypad, the up-down arrow keys, or by turning the knob. If we want to put a marker on the signal, just press the marker button, and you'll see to the right of the display there are 7 soft keys, the meaning of which changes depending on which function key we have pressed. And of course the most important button on the instrument preset button. Pressing the green preset button presets the instrument to a factory default state, clearing any strange settings that a previous operator may have used. Let's start by making some simple measurements for 2 GHz RF carrier that's being generated by this Agilent MXG signal generator I have here. You can follow along on page 7 of the demonstration guide. I've set the signal generator frequency to 2 GHz, the output level to -10 dBm, turned the RF on and connected the signal to the N9342C analyzer. So we press frequency, select center frequency and enter 2 GHz. That moves the signal to the center of the screen. Then we adjust the span to 10 MHz and you can see the signal more clearly across the display. Then press the amplitude button and we'll set the reference level to -10 dBm. If you want to measure the amplitude and frequency of that signal, just press the marker button and you can see here marker 1 is at 2 GHz and the amplitude is about -10 dBm. And if I turn on some modulation on the signal generator, you can now see we have a WCDMA modulated signal centered on 2 GHz. As you're probably aware, we can easily store instrument states and screen captures into the internal memory or onto a USB memory stick. In fact, while we're here, let's save the current setup into the internal memory of the N9342C. We press Shift, File, Save As. I'll select State, and we'll give the file a name. In this case, I'll call it A002, and then press Enter. And you can see that instrument state has been saved as A002 in the internal memory, and we can recall that later if we wish. But if you refer to page 8 of the demonstration guide, you'll see that the N9342C has another incredibly useful feature, where we can save up to 7 of your most frequently used setups to the dedicated user key here. This makes it much quicker to access and recall your most commonly used setups. So let's say with this 2 GHz spread spectrum signal here, every time we go out on site I want to measure, say, channel power. So if I turn on the channel power measurement, and I set the integration bandwidth to 5 MHz, and I'll set the span to 10 MHz, and we want to be able to recall that every time we go out on site, then let's save it the same way as we did before. Shift, File. But at this time we want to store it into a specific directory. So the user directory, and I press Enter, and in the state directory within that, so press Enter again, and then we'll go Save As. I want to select State File, and I'll give it a name. Perhaps Tony1, and I'll go Enter to save, and that's now saved in there. And perhaps we also want to frequently measure the occupied bandwidth of this signal, for example. So with the occupied bandwidth measurement up again, I can go Shift, File, and we're already in that user state subdirectory. I'll just go Save As, I'll select State, and I'll call this Tony2, and we'll press Enter. And now when I go to the user key, you'll see that Tony1 and Tony2 are presets already stored in the analyzer. So if we preset the instrument back to its factory default state by pressing the green preset button, and I now go Shift, User, I can immediately recall any of my favorite states with just a simple button press. With the RF spectrum getting ever more crowded, the ability to see transmitters turning on and off over time is a very useful function, both for interference analysis at base stations and for RF surveillance by the military and security forces. Turn to page 15 in the demo guide and you'll see how we can use option SIM in the N9342C to identify and measure signals across a wide spectrum over a period of time. In a real-world situation out there in the field, the choice of antenna is going to be as important as having a highly sensitive analyzer, such as the N9342C. But for the purposes of this demonstration, let's see what we can pick up with this cheap whip antenna that we've plugged into the analyzer. So following the instructions in the demonstration guide, we're going to enter a center frequency of 925 MHz. This is going to tune us in with one of the GSM phone bands, but if you don't have GSM around 900 MHz, just pick another frequency. It then says enter a span of 70 MHz. And the next stage is very important. We need to make the analyzer as sensitive as possible. So we're going to press the amplitude button and we're going to set the attenuation to 0 dB. We're going to turn the preamplifier on and we're going to set the scale per division to 5 dB per division. I can now adjust the reference level to bring the signal up onto the screen. And you can see here we've got a number of transmitters turning on and off. Now if I press the Mesh button and select Spectrum Monitor, you'll see the display is divided into 2 separate sections. The bottom section, if I press Run here, is the same live spectrum analyzer trace we saw previously, but the top section is what's called a spectrogram. On the x-axis, we still have frequency displayed, but on the y-axis, instead of displaying amplitude in dBm, we now have time. So each series, each trace is layered or stacked one above the other, giving us a historical record of all the previous spectrum traces. The amplitude of the signal is represented by the colour on the spectrogram trace. So blue is a weak signal and red is a strong signal. Now on the right hand side, the soft keys, you can see we can pause or run the spectrogram. We can ask the measurement to restart, which clears all the data and starts again. And also a very useful feature, we can set the update interval, currently set to 100 milliseconds, but we could select an update interval, say, of 10 seconds or every minute if we only wanted to capture a new trace after that period of time had elapsed. I'll leave it on automatic or 100 milliseconds for now. If I press the display mode button, we can either have spectrogram and trace, which is what we've got currently selected, just view the trace, or just the spectrogram. I'll go back to how we had it before. Now, here's the most important feature of this spectrum monitoring option on the N9342C, and that's the file logging button. What we can do here is save the record, the history of all these traces, either to the internal memory or to a USB memory stick. And we can start the logging process manually. I can press Start Save Now. And from that point onwards, it's now storing the trace records of every trace into the internal memory. I can stop it saving by pressing the Stop Save button. But if we wanted the analyzer to start logging automatically at a predetermined time, say coming on at midnight and going on until 4 in the morning, we can set the time setting here and give it a start date, start time, stop date and stop time, and it will then automatically start logging the spectrum at that predefined time. This is an incredibly useful capability that does not require an external PC. The logging is entirely done within the instrument. So if we now want to recall and play back that data we've just logged, I press Shift and File, and I can ask it to, we're just looking at trace files here, so if I scroll down, the very last one there, you'll see was recorded at 20 past 4 this afternoon on the 9th of March 2011, which is the one I've just recorded. So I can simply press Recall, and it's now loaded that section of spectrogram trace that we've just recorded. Better still, if I press the marker button, you can see that we've got marker 1 is already on. You may not be able to see it, but it's here on the yellow trace. And if I turn on marker 2, you can see here we've got another marker here, the white one. Now we can move that marker as with a normal marker in frequency. You can see here I'm moving the marker across the trace. But even more useful is that I can select the time value of that marker, and now we can look at the amplitude value at that frequency at a previous point in time. Sometimes I get asked how we can simplify and even automate a series of predefined measurements that a rigger or less experienced technician can perform automatically out in the field. Well, the new option TPN task planner capability of the N9342C allows us to do exactly that by stepping the operator through a series of up to 20 tests and automatically saving the measurement results of each test into the instrument's internal memory without needing a PC out on site. Let's say we want the operator to make the channel power and occupied bandwidth measurements that we stored previously for this 2 GHz WCDMA transmitter. First, we copy these state files, Tony1 and Tony2, onto a USB memory stick and transfer them to our PC. Now we'll use the free HSA software that comes with the N9342C to sequence them into a test plan. We can change the order in which the tasks execute. We can give each task a more descriptive name. We can enter a start message and end message that will be displayed to prompt the operator. We can set how many times each task should execute, or for how long. And in the report content section, we can tell the task plan what information to save to the test report. Marker values, pass-fail values, specific measurement results such as from this channel power measurement, the power value in dBm or the spectral density in dBm per hertz, and we can even tell the task planner to save the screen image or the trace values as part of the test sequence. We can tell the task planner how we want the operator to step through each of the tests, automatically or manually. Finally, we give the task planner name and description and save it onto our USB memory stick for loading back into the analyzer. So I'll press Shift and File, and you can see the media type is USB, and here are the files on the USB stick. We'll scroll down to the WCDMA test plan that we've just saved, and we'll go Files Operation, Copy to, and select Internal Memory, and Copy. So our test plan is now saved into the internal memory of the N9342C. If I press Enter, you'll see here it says Task Planner Overview. Gives the name of the task plan, the description we gave it, and the two tasks. So if I press Run, it says here the instruction that we typed in for the operator, connect the transmitter to the analyzer. So we'll connect the transmitter and then press Enter. The instrument's now making the first measurement, which is WCDMA channel power. It's saving the screenshots and creating a text file with the test results. Here you can see the measurements it's making of the marker value, whether it pass or fail, and here are the channel power measurement results again, indicating pass or fail. The operator then is given the options of redo the measurement, move on to the next measurement, or skip. So we'll press Next for the next measurement, and now it's measuring automatically the occupied bandwidth measurement we asked it to do in step 2 of the task planner. Again, it's saving the JPEG images of the screen, and it's added the measurement results now from the second task to our test report text file. We'll press Next and Return. And you'll see all the test results have been saved into a new directory on the N9342C called WCDMA Test Plan 1. If I press Enter, you'll see here the results of the tests we've just performed. The JPEG files of the screen captures and the report results, the test results, as a text file. And all of these can of course be copied onto your PC, saved and printed as required. And don't forget that now that we've created the task plan and loaded it into the analyzer, the operator can run all of these automated tests without the need for a PC out on site. Everything is contained within the N9342C, and all the results are saved directly into the internal memory of the analyzer. Thank you for watching this short introduction to the N9342C. For further information, please go to the website shown below. Here you can download datasheets, manuals, a copy of the demonstration guide we've been using today, and even request a free copy of the User Training and Applications Tutorial DVD I mentioned earlier. There's also a separate demonstration guide video available for each of Agilent's handheld spectrum analyzers. Each video highlights a different set of features, most of which are common to all models.